My research group is called the Flexible Electronics and Energy Lab, which is also called the FIELD. We focus mostly on several things. Let's look at, for example, an energy storage. You normally see you have these electrodes and electrolyte. And from the electrode side, we were trying to make sure this is really meet the requirements for clean energy. The clean energy, the ideal platform will be a solar photovoltaic with integrated with the batteries or supercapacitors and that kind of devices. So our group right now focuses mostly on supercapacitors, but we also try to expand to different kind of batteries as well. So from that standpoint, what we do are mainly two things. One is to focus on the biomass waste carbon. So we're using a lot of waste material like corn cobs, pine cones that people kick around on the street, and the shell of lobsters and shrimp and so on. Sometimes these materials that they meet certain criteria for an electrode, but not for many others. So what we're trying to do there is to try to modify it through some very simple layer by layer self-assembly kind of techniques, so that we can use some very good material, but only a couple monolayers, very thin, so that we can leverage the best of the both worlds to make the high performance and the low cost material for the future energy. So that's one area. And the other area that we're very interested in, we invest heavily, is electrolyte. Because currently, if you look at all the devices, they are mostly liquid electrolyte. So what we want to do is something as thin and flexible as these kind of devices. And so to enable these kind of thin devices, what we need to do is be able to develop something called polymer electrolytes. So those are the solid electrolytes. They are dry, so they don't have leakage issue, and they can be sandwiched in between the electrodes, so they are flexible and can be also implemented into wearable type of devices. So so we spend a lot of efforts in these kind of polymer electrolytes, and so that we can actually right now develop from the different chemistry to meet different electrodes, so that we have a bank of these polymer electrolytes to meet different needs. For example, printed transistors, so that we can have some of the devices being thin and flexible, but they are actually electronic devices. What's the application? In the field for the first responders or future soldiers, they can monitor. There's a lot of their bioinformation, and also for patients. Like, a lot of patients, they need to have the monitor. So that kind of thin, flexible devices are much better than these kind of big electrodes to go in there, to attach to their body, especially for seniors or for babies.